Okay. Hi, everybody. Jeff Dillon from Wayfair.com.
And Irena Shashchuk from Wayfair as well.
So we reached out to HashiCorp. We did a presentation with them in our building back in September, and we wanted to share kind of the bigger picture of presentation of some of the items that we did here at Wayfair, mainly around Terraform Packer and how we're using it for both cloud, obviously, and for our on-prem builds. We're going to get into a bit of two projects that essentially are going to sync into one. Towards the end of the talk, we're going to be talking about some of the items that we open sourced and some of the things that we're also going to open source in the future. And we're hoping that this helps any similar company or smaller startup that has a cloud footprint and a physical footprint within a data center. So to get things started, I kind of want to talk about, there's two obviously paths here that we're going to present, right? So there's a cloud project here at Wayfair where we have a presence within Google Cloud. We run production out of there. But at the same time, traditionally for the past 15 years, we've been a large data center on-prem, and we owned all the physical hardware. We're fairly large enterprise at this point, so we couldn't just simply abandon our three large data centers and move everything to the cloud. Those were built purposely for our business. They have value. They have tens of thousands of VMs already running inside them that deliver the website on a daily presence. But being this large, being able to scale out in burst e-commerce, which is kind of the name of the game these days, it's hard to predict that when your footprint is data center size. And that's where the cloud is playing a larger role with us. So you're going to see two interweaved talks here where we're talking about the cloud project and our on-prem project. And also sprinkled within that entire process, we're going to be talking about coding structure, folder structure, lessons that we learned, and we're hoping that also helps from like a development standpoint, people in the future. So we're going to do this chronologically. Irena and I are going to tell the story of basically the last 2 years here at Wayfair. To go way back, summer of 2017, that was our first hands-on with Terraform. We had a large project internally here called Image Cruncher. And for anybody not familiar with website e-commerce, whenever you load up a web page, the company stores the raw image and then sizes that image for you based on your web browser, your mobile, your phone, whatever's on there. That's a fairly expensive operation, and it takes heavy-duty servers to provide that. This was our first glass-shattering moment of why don't we run this completely in the cloud with cloud storage and cloud compute, work with our CDN for the image processing, and see if we can save quite a lot of square footage within our data center to move this traffic outside of the data center. So that's kind of like our first deliverable in the prod, and we thought this worked as expected. So that's when Irena and I, part of the SRE team, we kind of had a conversation, and we said, a large fear of ours is, okay, within SRE, do we end up with a cloud team and an on-prem team? Cloud's always going to be faster. If that's the case, we're not going to be able to compete with deliverables. Like, we're not going to be able to order servers as fast as you can deliver a Terraform G-Cloud command to build yourself an instance inside Google. And we started coming up with the theory of, can we have the same technology, the same stack, and the same team be able to control two separate clouds, a private one and a public one? And that's, from that point, we thought, okay, what are the three layers that make foundation that we're going to be missing right away? And like operating system, network storage, these are all things you take for granted when you deploy to the cloud, because they basically have all of that racked and stacked and ready to go for you. So let's jump back 1 second from that conversation and go back to the cloud project. So the Image Cruncher was a success. And that's when we basically said, let's go larger scale. Let's move some of our web front end into the cloud, balance it in a hybrid solution, and see what kind of results we can get into. So with that, not only did Terraform come into play, but so did Packer, so did Jenkins, so did Vault. We had to coordinate with Dyn, Akamai, Fastly. We had to figure out, for serving web traffic, how many different links of the spider web would we have to pull and understand to be able to actually utilize a business service in a hybrid fashion. This was probably around, what, February-ish, we started doing our open source commits, and you want to go into like the commit that we did to the cloud project?
Sure, yeah, and the first thing that we needed is kind of like with integrating with the cloud, the GCP provider was missing some of the functionality, some of like the data sources, and the biggest one for us was the resource for rolling out updates to instance managed groups. So like that was like one of the first commits that we made to Terraform and specifically to like GCP provider.
Yep. So let's move forward again, and let's jump back to the on-prem conversation, because now at this point in time, the cloud project is running. They are building stuff. They have a project manager. They have a team. They have an initiative. They know what they have to do to kind of deliver results, where the on-prem, we're still behind about 6 or 7 months' time.
Yep. So in order for us to kind of like jump into using Terraform for on-prem automation, we first wanted to try and get the feel of like what it is like to build the plugins for Terraform. So like, as we already had some experience with contributing to GCP provider, we thought like, okay, now it's a great time to kind of like start and writing one by ourselves from like start to finish. And the first thing that we decided to automate was the storage, and integrating with EMC Viper. So for those who doesn't know, Viper is a software-defined storage platform from EMC, and it pretty much creates a single pane of glass for all things storage that we use in our on-prem data centers. So the reason we chose that one is because they had a really well-structured and documented API. So for us who just started looking at Terraform and how Terraform works, it was pretty important to have a well-structured CRUD functions that align well with like Terraform resources, so that we can focus on figuring out the Terraform side first. We also chose it because it was one of the things that could be adopted by itself for like existing infrastructure. We didn't need the rest of the pieces, like the pieces that Jeff was talking about, like the OS automation or like network automation, to start using and start getting benefits from it. And it was also replacing some of the time-consuming and like repetitive tasks and kind of like giving a self-service to it. So how we approached writing that provider was pretty much, we just wanted to work. So we used the existing providers like GCP, because we use it most, and AWS as our kind of like guide. They were big enough to show enough of the use cases that we can kind of like adopt when we developing our own provider. And once we figure it out, we decided that we're going to test it against existing environment, because having a lab for this wasn't really feasible, because it's not just having a instance, like a Viper instance that you can test against. It also means having a physical server behind it and like a array behind it. So what we did, we tested against existing environment with like a restricted set of permissions that could only do the thing that we were testing for. And as we were done, we wanted to document the whole thing. So 1 month later, we have a Viper provider. And now we have an idea of like how to build plugins for Terraform. But it only solves one piece of a puzzle, storage. So now we want to present a solution that is more end-to-end. And for us, physical build was a big one, because it was spun across different teams, and it was like really time consuming to actually build a host from rec moment to like when it has OS installed to it. But that means we need to integrate with Things Network, which in our case is Cisco API, to configure the ports. And then we need to be able to set up a Kickstart environment for that specific host, and we're using Foreman for that. And we also need to find information about that host, and find the next available IP for that host, which is, in our case, integrating with device 42. And then if we want to go even lower than that, we need to do HP and Dell automations for configuring BIOS. And there's definitely more things that we are not bringing into initial scope, but want to be able to achieve at later stage. So we wanted to have a standard way of building those providers and having somewhat of a sample project that explains how to build the provider and make it fast. So anyone who has enough documentation can go in and start building a new integration point for Terraform when he needs it. So we came up with a number of standardizations that we use when building out the providers. First thing is just we are using the REST APIs for the majority of integrations. So we split off the API logic into a separate package presenting a Go SDK of some sort that we can use in Terraform logic and just keep Terraform logic pretty simple, so that the only thing that it does is just translates the API objects into Terraform resources. We also abstracted away some of the common functionality and moved it into its own shared repo that we can then import as a dependency package when building out those providers. That repo is currently open source, and we have a link to the open source package on this slide as well. So what that repo does is it has a good login package that allows to customize login verbosity per provider. And it also has a documentation builder package that will allow for automated documentation. So now when we are building the new provider, documentation is being built out as soon as you push that provider, as soon as you push the changes for the provider into the master. It just takes the descriptions in the code and translates them into the documentation that Terraform would expect. And then the testing is happening automatically. And as we tag the package, it just gets released to Artifactory so that pipelines can start using it. The glue that brings all those things together and actually makes a physical build, the glue that brings together all of the resources from those different providers are Terraform modules. So we're just, the modules just simplify for us what information the end users need to provide to actually build a host. We also create a new repo for every single new module, so that way we can, again, tag it and release new functionality as we want to, and then people can start using the version controlled modules in their end configurations by just referencing the tag.
So with that, that's kind of where we got to with the on-prem at that point. So if we go back to about springtime last year, inside GCP, they were obviously moving ahead and started actually building the foundations for data centers. And they were close to actually finishing full data center builds inside the cloud. One of the items that I also wanted to point out here is Packer. So not only just Terraform as a technology, but Packer within GCP, we are using this decision tree that you're seeing here of within that purple dotted line is where Packer would execute. So if you need something immutable, the decision has been made, build yourself a Packer image. That way we can destroy, repair, all those scale within all the scaling group, but these are the rules that we want to set for that model if you want to build up there. as you can tell, when we are taking cloud items and rolling them back to the on-prem, this is also another decision tree that we had to be aware of, okay, well, not only just the Terraform of building things, but we also want to plagiarize the Packer pipeline as much as possible as well on-prem, just to keep everything as unified as possible. So back to the cloud project, summertime, we're deploying data centers. We deployed 4 data centers. And what I mean by a data center is this Google instance is fully operational. It has Puppet, it has configuration management, it has network, it has storage, and you can start pushing business code there. We wanted to do that practice over and over and over again to prove that we can rebuild these in a scratch. We have all of the kinks worked out. We can scale them up and down. And at that point, we can then start testing what do we have to do to get part of our front end into this section as well. So back to the on-prem fall time, we made progress, right? We put all the cogs together, we put all the providers together, and we looked at the previous pipeline, and we said, okay, let's use the new pipeline and see what we can deliver. So previously, on average, to get yourself a physical server, you were looking at 14 days. That's for every single hop that conversation had to go through in order to produce something from human thought to in the data center, burn electricity, adding business value. From our pipeline, we got that down to a day. Now, for some of the folks on the phone, for on-prem to build something in a day is quite a feat, knowing that all the holes you have to go through for a 2,000 engineer organization. That basically cut out hundreds and hundreds of engineering hours that we were able to give back to the business, and from a single person, deploy a server into production. So now we go large scale. Right? Now we're into November and we're saying we figured out the engine. We want to see how many of these things we can build. For anybody else in e-commerce, you are awfully familiar with Cyber 5. That is the Friday after Thanksgiving going into Cyber Monday. That is a large shopping day for all internet traffic. We have to backfill and create quite a lot of compute to handle those days because it is very bursty. We're able to utilize Terraform on-prem to build these servers out and have them ready for us and not have to do any last minute long-term ordering of hardware to be able to meet the needs of that day.
So given the, now when you have an idea of the scale of how many builds we are doing on-prem and in GCP, I wanted to get to give you a quick overview of how we structure our Terraform code and how we break it down. So on-prem and cloud resources are all in the same repository side by side. The way we break them down is logically based on what data center it's actually going to. But sometimes that's just not enough. We are trying to be mindful of how many things the end configuration is going to end up building and how large the state file is going to get. Just for context, physical build requires over 10 data sources and builds over 5 resources for a single physical server. So if you keep adding them up, the refresh times for those state files are going to be really slow, and rolling out any new change will be just half an hour change, just because Terraform needs to catch up on all of the resources that might have changed prior to this. So we're trying to keep them small and breaking them down logically where it's possible. So on the right-hand side, you see how we break down a single service that has a representation on-prem and in GCP. Each of the end folders containing Terraform Terraform files is a independent Terraform configuration in a sense. It gets its own state file, it gets its own Terraform in it. So yeah, so we break it, so for physicals, we tried to break it down by the enclosures as well. So now your limit is 8 nodes per state file. That way we know that we can roll out changes relatively fast. We're also using Terraform workspaces. So where possible, we are using same code, but just different environments. So in GCP, where we have dev and prod environments side by side, we are using the same Terraform code, but just different instance counts for dev environment versus prod environments. And as I mentioned before, we are using, like all of our end configurations using modules. And we are referring to the modules by the tag, so that at any given time, your Terraform code will work as long as you're using the same tag that you used before. And I just wanted to give a quick overview of our Terraform pipeline. It's pretty generic. There is no code specific to on-prem or cloud. It's just a generic pipeline that checks out Terraform repository, runs git diff to figure out which of the end configurations actually changed and where it needs to run Terraform apply. And then after it does that, it runs some security checks and making sure that there's no forbidden behaviors or like no forbidden configurations that might to go out to production. And then it runs the Terraform apply.
So I wanted to thank everybody for their time. In the future for us, present day, we're building dozens of machines every week. We're in the process of terraforming ESX vCenter builds. We have self-service physical storage expansions. We're working on self-service VMs. In the cloud, we are operational and there is cloud traffic going through there. Long term, within the next 6 to 9 months, we will be combining these projects and it'll be the same flow, same team, same stack that with just a variable change could deploy to either on-prem or into the cloud. Irena mentioned before, but we wanted to post up here our public open source plugins. The first one's the utils library, which is kind of the skeleton that we were talking about for the framework for how we build these, and an example of one of them that we built, which is our Foreman one. Wanted to thank everybody for their time, and hope you enjoy the presentation.